Okay, welcome back, Dartmouth family. Today we are going to talk about how we can design an experiment. It's a lot easier than you think. Now, the first thing we have to do is realize, how do you conduct scientific inquiry? What are those steps? And it really boils down to just gathering evidence about the natural world and proposing an explanation based on evidence. Now, look at the diagram that's right there in front of you. It's not it's not one way, one set of steps, but it can change depending on what happens throughout your gathering of evidence. Um, if something doesn't work out, if your hypothesis is found not to be correct, then you know what? Go back and rework your hypothesis. If it is, then fantastic. Start drawing some conclusions and communicate those to other people. But if your experiment doesn't work out exactly how you thought, not always is that a bad thing. Sometimes it will lead to other discoveries. So scientific inquiry is not this step-by-step process and it has to be that way and that's the only way it can get done. It really does have a lot of flexibility to it. But you got to start somewhere. And so where you start is with posing a question and defining a problem. Once that question's been asked, then that problem needs to be defined. And of course, we get onto testing, which is the fun part. Now, you've got to develop a hypothesis. The great thing about that hypothesis is it is an answer to that question. It's not a fact. It's a possible answer. But you have to make sure that it's also something that you can test. Because, of course, when push comes to shove, you're going to be testing that hypothesis to see whether or not your data supports or does not support it. Not necessarily that your hypothesis is wrong, but sometimes data just doesn't support it, and that's okay. And so if it doesn't support it, then your hypothesis you need to go back and you need to rework it. Now, we know already that as part of an experiment, we have a few different variables. We have our independent variable and we have a dependent variable. We know that the independent variable is the one that is purposely changed. The condition that you are, as the person doing the experiment, are controlling. The dependent variable is the one that changes in response to the independent variable. So what you're measuring, the data that you're collecting, you cannot control it. We do have controls as part of our experiment. So what we would think the normal situation would be. And then, of course, because we have what that normal situation would be, we have what is called a controlled experiment. And in a controlled experiment, we have to make sure that only one thing is changing at a time. And that way we know that any of our results, any of the data that we collect are all because of that one variable. Okay, so let's talk about how to write a proper hypothesis. A proper hypothesis is written in an if-then format. So you want to start your sentence off with if. And now comes one of those variables. And we want to connect it somehow to the other variable. By, is it related to, is it affected by, causes. Then we write then. And then we make a comment on that relationship. So let's take a look at the picture that we have there. If a person is running with scissors, then they might get hurt. Perfectly legitimate hypothesis. Are we going to test it? Absolutely not. Let's take a look at the other example. If water is related to plant growth, then the more you water plants, the bigger they will grow. And so notice how we're making that connection between our independent and dependent variables. We are relating them. We are trying to draw a conclusion about what will happen between the two. Now, We want to try to avoid experimental bias, and that is an error in the design of the experiment. So not controlling all of the variables, maybe throwing out a sample because you're not happy with the result, failing to report all the results. We cannot allow any room for bias in our experiment. Now, we want to collect and interpret that data. The facts, the figures, the information, quantitative or qualitative. And we need to record it in some type of chart. And then in order to interpret it, we want to make some sort of diagram or a model or a graph. We've talked a lot about graphing, and so we know that a graph can really give us a great visual on the relationships between the independent and the dependent variables. They can help reveal patterns and trends. And then we draw conclusions. And we're just summarizing what we've learned from the experiment. Now, our conclusion might be that our data doesn't support our hypothesis. You've got to be objective. You have to have repeated trials. You can't do an experiment once and then think that those results are going to happen every time. And you want to know something? It is okay if your hypothesis is not correct. We are still learning valuable information about those two variables, independent and dependent, and how they relate to each other. We get to communicate those results. You get to stand up in front of your classmates or in front of other people and talk about your experiment. Be clear about it. Talk about how it can be replicated. Maybe another scientist is going to want to do that experiment. And drawing a conclusion from an experiment is a way to develop a scientific explanation. Generalizations that make sense of an observation by logical reasoning. So it's got to be logical, not like frogs flying through the air. Okay, I want you to go ahead and set up your left-hand side. We are going to create an experiment. Our problem, you observe that people who use freckle juice have lighter freckles. So your challenge is to design an experiment. I want you to state the problem. I want you to make a hypothesis. I want you to design an experiment. You are making a procedure. Don't forget that you need to be clear about your independent and your dependent variables and your control. We're going to make up some data. You're not actually going to test freckle juice on anyone, but you are going to analyze that data, and then you are going to draw conclusions. This is fictional, okay? We're making this up. So does your data support your hypothesis, or does it not support your hypothesis? Okay, have fun with your freckle juice. See you soon.